observe why it is abstract. Okay, why it is abstract. Okay, observe this one. Okay, why it is abstract. Now I am going to change this one as what? Interface only. Okay, I am going to change this one as what? Interface only. Just a minute, observe. Okay, by default they are what? Public abstract. Okay, now we are understanding why they are abstract, friends. Okay, it is what? Interface. Okay, now why interface methods are abstract. A simple thing. These implementation classes must and should have their own implementations. How we can achieve that one? If they are abstract only. If they are not abstract, can we get separate implementations? Yes, you can do get by overriding. If it is an abstract class, but it is what? An interface. Okay, that is the intention. Observe, it is having a number of advantages. Based on your requirement, you have to use that. Okay, now observe. Okay, now observe. Okay, what is this? Implement. Just the small proof. Okay, service. What is this? Service method. Let it be SOP of what? U. Okay, let it be the implementation. Within this, public static void main method. Now new U constructor dot service method. It is having some separate implementation, right? Yes. Okay, yes. If I do create one more implementation class, can it have separate implementation here? Yes. Observe here. How to prove that one? Observe here. Simple thing. Write one same thing. Okay. Change the class name. It will have separate implementation. You can have separate implementation. If you want me to prove, no issues. Have patience. Definitely I'll show to you. What is this? me.java. Let us put import.com.it.me class u-me which implements me, and let me override public void service method SOP as what? me having separate implementation, and other one is what? Public void acknowledge. Okay, and let it be. Okay, now public static void means string array. Let me take new u-me dot service method. Okay, if I do compile and execute this code, you will get me as the output. What is the output? me, getting me. If I do compile and execute this code, the output will be as what? Just u. Okay, observe here. Same interface, different child classes, different implementation. How you are achieving that one? Because of abstract keyword for these methods. Okay, observe. Just a minute to compile and execute. Okay, observe this one. Okay, observe. Just a minute. Let us go for that me interface. Let me put this one as what? An interface. Okay, interface. Okay, now just declare void service. Other one is what? Void acknowledge. Come here, come to the u class, put what? Implements. Okay, put what? Implements. Public void service, just change here as what? System dot out dot println as what? u. Okay, u. Okay, now let me create one more class which is having name as what? me, and it's having the implementation as what? me, getting me. Okay, let me have some differentiation. Let it be u-me.java. Let me save this one at D directory only. Now observe here, okay. Now let me compile this one first, okay. Yes, compile successfully, okay. Here you are having something, okay. Observe this one, how to run this particular two files, same thing. How to run them means, observe here the same thing. You have to run them in this way. Observe here, Java C -cp C class files of Java space u.java. Okay, this is for compilation. How to run them? Simple. Observe here. I have said to you one thing. Of course, I'm sorry. Compiler is always single level dependency checker. Meaning is I will consider this u.java within the current directory, no issues. Okay, you just give the class path to me, okay, for the dependent dot class file available within the other package, okay. And if it is available within the package, I will use this import statement. Observe here, okay. So compiler will ask only for the dependent dot class file OS directory structure and package directory structure, okay. But JVM will always expect, okay, both dependent dot class file and current source code, okay, current source code path, okay. Now observe here, how to run this u.java Java -cp C class files of Java and set current working directory also, so that it will have the knowledge of this source code also. Observe here, okay, how to set the current working directory class path by using D, or else you can go for what? You can go for just dot, okay, space main method corresponding class name. That is what you, if it is you me, the same thing, okay, same thing till here. You have to put u-me. So here you will get the output as what? U. Here you will get what? Output as what? U, me. Observe here, different child class having different implementation. Because of which keyword? Because of abstract keyword, okay, because of abstract keyword, because of that only you are achieving that one, okay. And why it is declared as public? To access from the outside the package. Who should access? Child, that is implementation classes, okay. Now observe this one, okay, observe here, okay. Now let us create, yes, we have done with all of these things, okay. Now go to the D directory, compile it, compilation successful. And now let me compile u.me Java file, okay. Observe, compiled successfully. Let us go and check u-me dot class file generated or not. Observe, yes, it has been generated just now, okay. Now let me run them -cp C class files of Java current working directory dot. Observe this dot, friends, okay. Now, okay, you should get u as the output. Observe here, what is this? No such method error main. Yes, we have done mistake. What is that? We didn't put main method, okay. Let me write that main method, okay. Just a minute, observe, okay. Let me put that main method within the u class, okay. Now public static void main string args, okay. Now what is that? New u call service method, okay. Now let me paste the same code within the u-me class, okay, but the constructor name will be as what? You hyphen me, okay. Let me compile this one once again, okay. Now let me run that, let me compile you also. Now go and run that you dot class file. Observe here, yes, what is this? You hyphen you, no such method error, main. What is this? One second, you, okay, 1 second, we didn't get the reflections, okay. Now yes, save, okay. Now open this one, okay. Now it has been created, okay. Just in earlier case it didn't get save, okay. Observe, okay. Now delete this one, okay. Now delete even this one. Now yes, it is fine, okay. Now open this one. Now it has been created. Now go and compile them, okay. Compile them, okay. Now compile this u.java, run that particular thing, okay. Yes, it is what? U, okay. Now let me run you hyphen me. You should get star me dot, okay. Getting? Yes, we are having different implementations from different child classes. Why we are getting this one? Because of abstract modifier, okay. Now observe here, okay. Now what is the other thing as part of this interface methods means? Observe, okay. Observe, what is that means? First point, observe whether the programmer declared or not. Whether he declare or he don't declare, okay. These methods will be as what? Public and abstract by default. Now observe whether, that's why I have written here, I am highlighting this point, whether programmer declared or not declared, they are what? Public and abstract, okay. Observe here, okay. Observe here. Now let us see some of the valid declarations. Let us see some of the valid and invalid declarations of interface methods, okay. Interface methods. Observe here, friends, okay. Simple thing, okay. Now observe. Now I can declare an abstract method like this, okay. Abstract void m1 method within the interface, which is valid. Observe here. These methods, okay, the methods within interface by default will be public and abstract, whether he declare or he don't declare. It's my option to write abstract and it's my option to write public, okay. So this is a valid declaration. And observe here, if I do write a method public void m1 method, still it is valid declaration. Just void m1 method, yes, valid declaration. Now observe here, abstract public. Can I interchange the modifiers? Yes, you can interchange, but you cannot interchange these two things, okay. You cannot do that one, okay. You can interchange these two. This one is not possible according to the syntax, okay. According to the syntax, okay. All these are valid declarations. And public abstract void m1 method is also valid declaration. All these are what, guys? Valid declarations, okay. Valid method declarations, okay. This one, okay. Now observe this one. If it is like a public, yes mister, I want to declare some other modifiers and access modifiers to these methods within the interface, okay. You are having some restrictions. What are those? Observe here. Some illegal combination of modifiers with respect to the public. Observe here. If a method is public, it is having higher accessing nature, okay. privileges. If it is like public, can you declare that one? I mean, this public is what? By default, okay, default nature. Getting, who is giving? Our Sun Microsystem is giving through compiler, okay. Now can I write a method within the interface with private? No. With protected? No, you cannot write. Observe here. Private you cannot do, unprotected you cannot do, and default you cannot do. All are invalid combinations. Of course, now it is abstract. By default, interface methods are what? Abstract. Now let us see some illegal combinations of this for this modifier. Okay, observe. Okay, what are those? If it is like abstract, we are having some illegal combinations. What are those? Observe. What are those? Observe, friends. Okay, final. These methods cannot be final. Other one is what? Those methods cannot be native. Other thing is what? Those methods cannot be strict. FP. This is with respect to the methods. Observe. Okay. Now those methods cannot be static. First of all, no static declaration is allowed within the interface. Observe. Okay. Now other one is what? Synchronized. Getting? Other one is what? Synchronized. And we are having, of course, private has come there. Okay, no issues. These are some illegal combinations with these abstract methods within the interface. Getting? Observe. Okay, what we have learned here, let me brush them once. Whatever the method declared within the interface or by default public and abstract. Why they have made that one as public means simple reason. What is that? Why they have made that one as what public means? Simple. To make child classes to access, that is implementation classes to access the methods from outside the package. We have seen good example, okay, by changing an interface to abstract class, okay. And why they declared all the methods as abstract within the interface? We have even seen one example for that one. What is the reason? Different implementation classes must have their own implementations, okay, their own implementation. This is the only reason why they have made abstract, why they have made methods within the interface as abstract, and why they have made public. Simple thing, all implementation classes must access the interface methods from outside the package, okay, from outside the package. This is the only one reason to make them as what? Public, and this is the only reason to make them as what? Abstract, okay. Now other thing what we have seen, it is by default public and abstract, okay. If it is like a public, we cannot declare abstract methods as what? Private, protected, default, and by default those methods are what? Abstract. So you cannot declare some of the modifiers to which abstract methods, that is interface abstract methods. What are those? Final, native, static, strict FP, synchronized, okay. This is what our interface methods. This will help you a lot, okay, if you want to go to higher technologies of Java, okay. Now